Have you ever wondered how the future of AI can be unlocked by leveraging scalable data solutions that are tailored specifically for multimodal applications? When I talk about multimodal applications, you can expect to understand the data that is coming in different forms, whether it is textual data or whether it is visual data, or maybe whether it is voice data or video data. So any forms of data. So there is different forms of data that is available there, and how do you analyze? How do you manage this data and search the data and use it in real data science and machine learning projects relevant for AI? If that is what you're looking for, you are in for a great treat today. And we are thrilled to welcome Vishakha Gupta, the CEO and co-founder of Aperture Data, to our XTraw AI podcast. With a wealth of experience in designing purpose-built databases that are revolutionizing how we handle complex multimodal AI data, Vishakha is here to share some insights that could reshape our understanding of scalable AI solutions. A bit of a background about Aperture Data. Aperture Data is pioneering the integration of visual data in metadata, enabling more efficient and effective processing of multimodal data sets, crucial for the next generation of AI applications. And here, Vishakha's experience in this space will provide us with a deep dive into how these innovative data solutions can unlock new potential for AI technology. As always, you'll find more information at the end of the podcast. So sit back, relax, and enjoy the podcast conversation. All right, welcome back to our XTraw AI podcast series on AI and machine learning applications. So today I have an interesting topic, unlocking the future. We are going to talk about scalable data solutions for an AI-driven world. And today I'm thrilled to have Vishakha Gupta, the CEO and co-founder of Aperture Data, with us. Aperture Data is the forefront of scalable data management and search solutions, ensuring that vast amounts of data are not only secure and accessible, but also AI ready. So to get started, maybe Vishakha, can you give a little bit of a background about what inspired you to be or to co-found Aperture Data?
Hi, Raghu, and thank you so much for inviting me to the podcast. This is a very interesting topic, and just feel free to stop me if I go on for a long time on this. But my background is classically computer science. I did my undergrad in India in BITS Pilani, computer science, and then I came to US for master's, and then went on for PhD from Carnegie Mellon and Georgia Tech. And the courses I took and everything I learned, very core computer science research. In fact, my PhD thesis was in how do you schedule in hypervisor systems when you have different sorts of processors like CPUs and GPUs. So when I went ahead and joined Intel Labs, I had worked a lot on the heterogeneous processor systems. And then I kind of got into this whole heterogeneous memory system. So you have DRAM, you have, and the research on non-volatile memory at the time was like pretty much peaking. There was so much you could do. There was like, how can you change applications? What does it mean for databases when you have these memory systems that are going to be almost as fast as DRAM, way faster than SSDs, much larger, and maybe you can do load store access, right? So natural question there is like, what happens to databases? They're like such big consumers of data, and they definitely require a lot of in-memory stuff to make them faster. So that kind of drew me towards working on this graph database project. So we started building a persistent memory graph database. So what does it look like to have your data structures living in memory and doing load store access? Because traditionally, if you look at graph databases, they suffer from the whole, it's connected data, which is great for representing real application. except when you have to implement them on disk-based systems, it can really slow things down. It can hurt scalability. And here we had this opportunity, like you could be treating it as an in-memory application and build the graph database. So that was one of the first projects that got me into like, okay, well, database systems, like how do you build it for all this heterogeneous memory and storage hierarchy? Because, we are also like the cloud, with cloud growing. Now you can imagine the challenges there. You have memory, non-volatile memory, solid state storage, you have spinning disks still. And then you're talking about not just distributed file system, but cloud object store. So it made for a really interesting set of systems and database challenges. But around, at some point, what ended up happening was at Intel, we started looking at how do you redefine cloud systems when your workload is primarily composed of, like, you're dealing with complex data. You're dealing with image video type of data. And not for streaming, but you're going to be using it for machine learning. So this was around the time, ImageNet started growing popularity. Everyone was talking about convolutional neural networks, deep neural networks. How do you detect? How do you classify? How do you train models? And of course, there the big challenge was, can we train it to see what we see? And there are so many use cases, right? So Intel defined a science and technology center around it that involved researchers from the labs. So us, my team, and researchers from Stanford and Carnegie Mellon. And we were looking at the entire, collect data at the edge, run some inference there, send it all to the cloud, and then run batch processing to learn more and train better models. So that kind of got us thinking, where does this data go? What are the characteristics of the data? How do data scientists and machine learning people use data? What do their workloads look like? What are the steps that happen in a classic machine learning application? Because you can say it's one application, but there are challenges in data collection. There's labeling, curation, there's training and validation, there is inference, and then there is analytics. So there's you've seen the diagrams on the whole industry now, and each step has spawned so many different companies. And we were thinking, being the classic systems people, well, this is an application. What does it require from the data? Can we take an overall perspective as the entire pipeline? How does it interact with the data? Maybe the metadata? How do you find what you need? Do you need to process this data? Are there databases that are built for handling unstructured data? Are they built in a manner that it's easy for data scientists to work with? And so, that kind of led us to building this visual data management system, is what we called it at the time. And then, more and more we started to talk to people in different verticals: healthcare, retail, sports, media. We wanted to offer something out of what we had built that they could easily deploy in production. And that was outside of a research lab's mandate. And, the work was very inspiring. There was so much to be done that we're still not done with it. And I was also curious, what was it to do a startup? What did it mean? How do you grow it? How do you build it? How do you offer something that people care about? It also on the side worked with the family. So all that put together kind of inspired, and we have Aperture Data.
Beautiful, beautiful. I really appreciate explaining your journey on how you started, right from your research projects at Intel, and then how did you take and how did you put all that into perspective, and how did you build or come up with the idea of building Aperture Data? Maybe I think we'll take a quick break, come back and get into the real meat of our conversation for today's topic.
Sounds good.
All right, welcome back. So that's a great introduction that you have provided, Vishakha, and for our audience. So, but before getting into the actual nitty-gritty details about unlocking this scalable data for AI purposes, I would first want to go back and maybe get into this question of how do you see the role of these purpose-built databases for multimodal AI in this era of generative AI? I know you briefly touched on the aspects of graph databases and all, but do you want to give a brief, what are your thoughts about the role of purpose-built databases for these multimodal?
Yeah, that's a great question. So, I like to start from like step one, what's multimodal AI, right? Because I think the terminologies have gotten so overloaded on a lot of different things. So I have my own cheat sheet on understanding some of these things. And to me, the goal of AI in general and multimodal AI in particular is kind of to get close to how humans think. And that means, we process different modalities of data to arrive at our day-to-day decisions. We see, we hear, we read. And that means for AI, it's images, videos, audio, text. And now classically, these data types and ways to search them have been supported by different data tools. So, you typically, the metadata describing them would typically be put in relational or key value stores or graph stores. The data itself will land in cloud buckets or like file systems. And then lately, because we can extract signatures from these complex data types or embeddings, it makes it possible, even without keywords and without that metadata, to be able to find, at least land in the near vicinity of the type of the data you're looking for and do it faster with vector searches. So you have vector databases for similarity search now. But with all these different data tools, it places a huge burden on machine learning and data science teams that need to bring these things together, to use them to feed into the models so that something valuable and accurate can come out of the models. And it's not just software tooling to read and translate, right, which is already expensive to put in place, but also complexities of enterprise data management structures. Often, the natural thing is that they are siloed. Everyone has, like, typically you've needed the traditional tables for one application. You've needed images and stuff just for, let's say, an e-commerce company just to display product pictures, but not really do much more with it. And the teams handling all these data types have very different goals. Syncing across people, getting them to agree mainly to, break the security silos, put in place for so long for good reasons, and then find ways to get permissions, bring the data together. It's too long and varies per use case. Now, if we, instead of this sort of we make our own combination, if you replace that with a purpose-built database for this particular, for enabling multimodal AI, what are all the things that you can do? You can address some of these problems at a more fundamental level. For one thing, it can offer you a unified location. So let's say you got all the permissions you needed. You need some place to land this data. So it gives you a unified location to put all of these things, to put all these modalities together. You can already enable searches, whether it's by keywords, labels, or embeddings, or a combination to find the data you want. And if you know how the data will be used, let's say you are going to display thumbnails of images, or you are going to speed 1 frame per second videos into your model, you can already support some of these pre-processing or augmentation operations so that they happen close to where the data lives, instead of transmitting the large data and then processing it into the format you need. So if you combine all of these things together and put it behind one system that understands the applications and knows what to do, you can build it to scale. And you can hide the complexities of dealing with all these data types behind a query language that makes users think that they are querying one system, but getting anything that they require. I mean, behind the scenes, you have to make sure all these data types still work together, but it gives you the opportunity to get an overall view, give the users a simpler interface, but still do the optimizations behind the scene to make all of these things work seamlessly together. And it's basically, the way I see it now is you want to benefit the models, but you have to take a data-centric view for supporting multimodal AI in general and Gen AI in particular, where knowledge graphs and vector searches are already the key ways of finding data.
Beautiful.
That's how I think purpose-built databases give you that opportunity to take a stance in terms of, this is what these applications are going to need. Let us find the best way to combine, scale, but still hide complexity from the users.
Beautiful. You've laid out the complete picture very well for the audience. Now, I would like to want you to hold on your thought on that, and I would like to ask you about, you've been interacting with a lot of enterprise customers and consumer software customers or retail and other customers. What is the typical challenge that these customers are facing? Because there is not only now vast amount of data that they are going to look into, but also different models of data, like you have explained. If you can highlight, like, what are some key challenges that they are facing, and how AI is making these things address in a better way.
Yeah, so I want to take machine learning and data science, or like AI side view to the question that you asked, right? Enterprises have managed terabytes or petabytes of data traditionally.
Right.
There's cloud buckets, there's distributed file systems. There's also databases that can scale, but the use cases and situations are now different. Struggles are more in changing perspective. We have a newsletter that talks about all these practical challenges in deploying and managing data for achieving success in AI space. But I think if I were to list some of the key challenges that we've encountered, the very first thing is enabling the consolidation of all this data. Because, if you want the AI teams to achieve what you want them to achieve, they need access to the different data types. So, but that breaks and that goes against like everything we are taught about. Don't unnecessarily grant permissions. Keep the data only accessible to people who really need it, and review and revoke permission. That's like, especially in big companies, when they are like so worried about data being protected properly, that's always like a big thing. And now you're saying, no, bring this all together and let the whole data science team do something with it, right? And then we go into like, when these teams are, let's say they get access to the data or get access to some part of the data, they need to augment or pre-process the data to make it machine learning ready. They sometimes create copies. Even if we were to discount the cost of doing all that, cost of creating copies, cost of executing these augmentations, if you cannot track down where the original data came from, if you don't know how many copies of that data were made, you run a very high chance of breaking compliance.
Right.
Like if you need to, let's say someone asks, okay, I got to delete images from all the images that have come from this source. If you don't know where all they were replicated because you lost track, because some people just created copies because they couldn't work with the systems and access them over network, that creates a compliance problem. Then it's also heavy on cloud costs. When you're dealing with large data and you suddenly need to copy it or chunk it in different ways or augment it, we run into this sort of problem. It was one of the motivating examples for us. We had someone tell us, it's like, I only need one frame out of the 30 frames of a video, but our videos are 2 GB large. Every time I have to get the whole video just to extract the one frame each, like in every 30 frames. I need a really big machine to do it. I need enough memory on my system because it also has to run the model and support that data transfer, right? I was kind of like, and that was one of the things we had gotten to thinking, there got to be something better. Like, can we not do this differently? So that's one of the challenges. Then we also run into, especially, classic machine learning is still thriving. It's in fact like finding a footing, where then you get into labeling and annotation challenges. So you need to be able to create data sets that need labeling. You need to manage the versions. You want to share it safely with labelers, especially if they are external to the company. And whatever annotations they give you back, you need to land them. And the way people have been doing, passing around buckets of data, which you don't know how they were named, you don't know how many were passed around, you don't know where they landed, especially if somebody leaves. All of these, and that's not to count frame level annotations or like, little portions of in a long file, little portions that need to be annotated. They kind of create a lot of scale and security and all these sort of challenges. And these are just a few of them that require special infrastructure work and time. And that time part is now the enemy against moving fast with AI.
Beautiful. So I think you have highlighted many aspects of this, and you also have touched upon the aspects about the security challenges and also the compliance challenges and also the accessibility challenges, in addition to this vastness of the data and the multimodal aspects. So before we get into how Aperture Data is addressing it, what are the steps that the enterprises need to take before even thinking about what kind of a tool or what kind of solution I'm going to use? Because these are now you have to make it AI ready, right? What are the
Right.
minimal steps that you need to take on the enterprise side?
Yeah, that's an interesting question. It I would say it sometimes varies by use cases, depends on what you want to achieve in the end. Sometimes if it's customer facing versus something you want to do for employees. But in general, if data involves images or videos of their customers, for instance, in like a retail checkout example, there are people buying stuff, right? And then that's the data that you can't send around unencrypted, and you can't send it to anyone and everyone. It's very restricted. Like oftentimes they have deals that they won't even use third-party cloud, or like they would keep the data within their virtual private cloud, right? But so you need to guard it, and that often means that the data management, whatever they use, needs to be deployed within their VPC, or it takes a while to evaluate trust if they are going to work with a partner. Then they have to kind of come along with a policy on who gets permissions to what part of the data. Like that was one of the things, like who gets access to the data. And there aren't very standard solutions to it. So even before people can agree to deploy these things, I think one of the things that I guess leadership involving different parties, they have, and the different parties, I mean, the IT side, the SRE side, the data engineering side, the data science side, all of them have to come together and understand, okay, if you want to achieve success from AI evaluation, you cannot just say, take a handful of data samples and achieve it. Now, that's something that the data scientists can bring, right? They can tell you that you are going to need a broader perspective and understand all of the data. And then the data engineers can tell you how challenging or not would it be to ingest and what format it's going to be needed. And then the IT and SRE teams have to figure out like, okay, we are going to enable this, we're going to keep it for limited time, or we are going to make sure that the access goes through certain, a certain type of API or certain type of protected way, but everyone gets access to it. And this is how we manage, and that's where you start getting into tooling, what can let you achieve this. But I feel like there is a discussion to be had, because too many times we run into a situation where different parts of the companies don't understand why the other part is asking for something. And I think to your point on what do companies need to even think about before getting into the tooling space, I think they need to get an understanding of there are certain things required so you can claim success or so you can get to success. If you put blockers in that, it just is going to mean subpar outcome. And you can't blame that AI doesn't work if you don't give it the tools and information needed for it to work, for the teams to make AI models work. So I think there is some amount of like this understanding that people need to arrive at, some sort of rules in terms of, and I can see challenges from the IT and SRE teams. They are responsible for compliance. They've made certain guarantees on how they'll protect data. But a lot of the times, the data science and engineering team might be more interested in quickly prototyping and forget some of those standards. So like, what are the safeguards? What are all these things? So I think there needs to be that discussion, and it needs to be really obvious, because you can't, because we end up talking to the different stakeholders, we realize when they ask certain questions, and we're like, but why didn't they discuss this? Why didn't they figure this thing out? Why is this still a confusion? And then we are like the go-between saying, no, you guys are going to have to do this because ABC. And oftentimes it has happened that when we do demos, we first do a demo to like the data science or ML teams, because most of the querying part is what they would benefit from. And then we get introduced to like the data platforms and engineering team. Their questions are more around deployment and all that. But before that, they're like, why does the data science team need all this? They have this tool and that tool and that tool. And you can hear the data science team then telling them, yeah, but combining this and that, I have to translate all these things, and then I just end up offline downloading all of these things, and I can't visualize all of my data, and then I don't know how I'm training the model. And then they're like, oh, yeah, okay, now we see the disconnect in what we were offering and what you guys need. So I think it's
Beautiful.
mainly like establishing those communication paths and understanding.
Beautiful. I think the important aspect here is that I think all these different stakeholders within an organization, when we are talking about understanding these different models of data and different aspects of this data, whether it is huge or vast or different types, I think the first thing is that you have to be aligned and you need to maintain that proper balance and then get into the tooling aspect. Now that we talked about these different aspects of the multimodal, the data and the vastness of the data and how you are getting the data. So now I want to really, I know I understand the aspects of the balance that is needed and how these different stakeholders have to work together. And now all that is understood. Now let us go into tooling aspect. And this is where I would like to spend some time understanding the background of Aperture Data. I know you gave a very good background of Aperture Data and how you have formed. But now I would like to go a bit more understanding Aperture Data's mission and vision statement and how you are effectively working with your enterprise customers or consumer software customers. And then maybe also talk about how you are addressing these needs using Aperture.
Yeah, no, that's a really good question. So there is a lot of good we can achieve with AI. And I'm coming straight from learning about drug discovery, cancer solving machine learning use cases, discussions, and worker safety and great customer experiences. It hurts if bad infrastructure is what sets these efforts behind by even months, let alone years, right? And as systems programmers, we've seen operating systems, middlewares, databases solve big data and application problems for decades now. We always come up with innovative ways. That's how we have all this, different types of databases and stuff. So the question we asked is, why can't we simplify the life of data science, machine learning, analytics teams so they can easily work with the data and make these wonders happen rapidly and cost effectively? So that's been the driving vision for us. And our mission, I would say, is to be the de facto data layer for multimodal analytics applications. Just like, if someone shows you employee records, and you naturally think, should we store this in Excel or Postgres or some relational database? So we want teams to see that if they need easy search and management of their text and multimodal data and metadata, and they're going to be building these complex applications, their natural thought is, oh, let me use ApertureDB because it delivers on the requirements, it's easy to get started with, and it works seamlessly with the rest of your ecosystem. And to give you, I think you asked another question around some examples of where we've been solving problems. So I'll just pick a few concrete use cases in the verticals that we've been in, right? Of course, when you start with an infrastructure tool, it can go into a lot of different verticals. So the hard choice becomes, especially as an entrepreneur and an early stage startup, you have to make a choice. Which domain are you going to go into? And for us, after some amount of discussion, we started out with e-commerce and retail. So a few of our examples are in those spaces, right? Like imagine a situation where when you are buying something, as a buyer, when you look at like a piece of clothing, furniture, you see what it looks like. You feel the texture. You're thinking about the pattern. Does it fit into your living room, or does the clothing look nice on you? You're not thinking about, most of the time, you're not thinking about my friend bought this or my neighbor bought this and that's why I should buy it. It's because it really appeals to what you see. In order to achieve that like on an e-commerce website, that means now you got to start recommending based on visual features. And that sounds like, okay, as people, we can see it so easily, right? But if you go behind the scenes to make it happen, first you need a catalog of all your products, including their images from different angles. Then you need to train your machine learning model to recognize the patterns, the colors, the shapes, and correlate them with what something else looks like. That's when you extract embeddings, you got to index them, and you can do similarity searches and recommend. So this is that whole cycle I was talking about, like the whole machine learning cycle that I was saying. You got to index the data, you need to make it searchable, you need to feed it into a training and validation step, then you're extracting embedding, and then you do vector search. So you can see there was an interaction with data and metadata at each one of these stages. And this is where that whole combination system would come into play if there wasn't ApertureDB. So, we've been working with a Fortune 50 home improvement retailer on a use case that's similar to this, where what used to take the data science team days to query and create these data sets and enable this vector search now takes a matter of minutes, because they can catalog the images and product information in ApertureDB. Then they can use those images to train the models. They can query it from Aperture easily. We have integrations. And then they can index the embeddings that they extract with that model back into Aperture. And then they can enable really these complex queries. Find me something similar, but make sure it's from the fall 23 catalog. Like combine the vector search and the metadata example, right? And it's all happening in one place. You're not exploring 5 different tools at this point to make it happen, and nobody's writing their own ad hoc scripts to make it happen. So that really, it can boost productivity like 10 times sometimes, depending on the scale of data and complexity you are dealing with. So that's one example. Then there is on our website, we have a case study with Badger Technologies, which is the Jabil company. They do inventory, they do inventory management right now, mainly deployed in some grocery stores. And they have a robot that goes up and down the aisle and makes sure that the aisles are populated and the products are not misplaced. Because as customers, when we go to a store where you can't find what you're looking for, it's really frustrating. Especially you take time out, you go to the store, and then you're like, you can't even find it, right? Or if there's a pricing mismatch, all these things hurt the stores and the brands. So this robot will go up and down, take pictures of the shelves, convert them into vectors, and do vector search at scale. So it's a soft real-time example, because they have to figure out the classification labels right away. So they evaluated over 6 vector databases at one point. But they were scaling really fast. I think they're deployed in more than 300 stores now. And these robots are doing thousands of vectors per second every morning. So either their option was wake up every morning at 5 and make sure nothing crashes on the database side as they are reaching peak scale, or we demonstrated to them that we can actually handle double the amount of scale you're at right now. And that's something that they really liked. And the way we worked with them and demonstrated all this, they have been pretty happy about the way we've been scaling. And they don't have to worry about the data infrastructure as they're adding new stores. All those kind of examples makes it really, it gives a really good feeling. And then there are video training examples in a frictionless checkout company. And then we recently started working on a biotech use case we are really excited about, because that's when, I was talking to you about like the helping solve big problems that we can enable with that infrastructure support. That's around, indexing a lot of images, helping create reports for the rest of the team on what sort of experiments they ran and things like that. Then we have an interesting mortgage lending LLM, sort of like, a Gen AI use case, like sifting through information and helping mortgage lenders. So these are just a few. We have also been exploring, like when people want to enable worker safety, they need to train the models on data. They need to capture events and all the sensor information around it. And that's different. Like it's videos, it's maybe some other sensor recording that happens. Maybe it's defect detection, it's the same situation. So it's all these different modalities, and they're always searching by like, I want to know what happened at this location at this time, which is the metadata.
Right.
And then sometimes I want to find images that have this defect or this sort of violation or this sort of safety problem, which is a vector search. And then they actually want the data, and they want the data accessed in parallel. Sometimes it's millions. So these are some really interesting use cases. There are a lot that I learned. I didn't even know it was possible. So that's the part I've enjoyed a lot. As you know, ever since starting the company, I am required to talk to customers, but I actually really enjoy because they have such great perspective and applications that I don't know. Maybe I just like that level of imagination is just like a whole new level, which I really appreciate, and I get to learn about it and support it.
Beautiful, beautiful. I really enjoyed, I think, your the way you have explained these two examples, right? I think I could easily picture in my mind, I think, the efforts or the pain that people go through, and now attaching how ApertureDB kind of companies and specifically ApertureDB here, how you're solving the problems. So a follow-up question to that, I believe you'll be available, your service is available, ApertureDB, the tool is available, integrated into the solutions, or are you available as a SaaS solution? Do you want to talk a bit about that before I go into the most interesting question of our podcast?
So we deploy. So we are now a distributed database. We run in different. We are cloud agnostic. For for customers who are really concerned or who have agreements with their customers that they will not send the data outside of their VPC, we can deploy ApertureDB in their VPC. We kind of made that choice because of the kind of data we are dealing with, even though it's of course easier to have people use our self-serve cloud, which is launching in October. So while we host, we just migrated one of our customers into our cloud host, like our hosted cloud solution, instead of like move them from their VPC into our cloud, and we're doing more and more of that. But we do deploy in VPCs. We can deploy on-prem, but with more effort. So we need someone on the customer side and make sure they give us access, and we work closely with us. And we can be instantiated from GCP Marketplace as of now. There'll be some other ways coming. We have a community edition for people to prototype. So we have our Docker available that people can download, try it out. We have a public Slack if people want to ask us questions. So given how fast things change, and given how the teams need to build proof of concept before they go to leadership to get approval, we realized by that if we put barriers to entry, it wasn't helping anyone. And so that's why we kind of made the Docker available. So at this point, basically which deployment model that people can start with, we'll work with them on it just to make sure they get the data management support they need, and then they focus on the AI part.
Beautiful. I think the data management support as well as searchable support because when you're working in these different locations and different images or videos or different things, and getting the right data and how you can leverage that in your data science or your data machine learning lifecycle. That'd be beautiful. So I think I try to term this as the $1 million question or the $1 billion question in our podcast or XTraw AI podcast. I know there is competition out there. How do you differentiate yourself from the competition, or what is that uniqueness? I know we talked about it a bit, but if you would want to elaborate or highlight that a bit more, would like to hear from you.
Yeah, it definitely is a very crowded space, and not just data management, but there's just so many tools, and a lot of the messaging out there just sounds so similar that unless you go into the next level details, it's kind of hard to distinguish, right? But I think I view the key to our differentiation is in the blend, like how we've blended these technologies together. There's of course technological, like I could go into how we've implemented the graph database really fast, or how we've enabled the transactions around all these different data types to support database benefits. But really, there's a diagram that I have with the spaghetti solution. These are all the things you're going to have to put together that I show. And the reason I show that is even with the best intentions of using the right tool for a specific data type that you've traditionally learned, Vector databases solve an important problem. High dimensional indexing, search, classification, it's not easy to do. Graph databases help you build knowledge graphs. Distributed file systems, cloud stores, they'll help you manage large objects. And they'll help you read them at scale. There are libraries like FFmpeg, OpenCV, audio processing libraries, PyTorch, frameworks like LangChain and LlamaIndex that help you process the data into the required format. The problem is, from a user standpoint, what you worry about is going from some input to some valuable output. And for that, all of these tools that I mentioned, for machine learning use cases, users need most of it, or in some cases, all of it. And we lead them to build that combination themselves, often leading to this Frankenstein sort of patchwork solution because they are pressed for time.
Right.
And oftentimes, and they have a lot to achieve, and they have a lot to achieve with data. Software engineering is not their mandate. Data analytics and insights is their mandate. And I think the key thing that ApertureDB differentiates itself in the market is we deliver these things behind a unified API. We support the entire AI pipeline, not just part of it, and we do it in a cost-effective and scalable way. And individually, we've been looking at, if someone is just looking at vector databases, how are we different? We are faster than a lot of vector databases out there. Our latencies are, surprisingly, like people are like, wow, that's fast. And we support text and multimodal vector searches. And even the better part, which I don't, as far as I've done research, nobody else does, is easily combine the graph filtering with vector search behind the scenes, like in an integrated, seamless manner. So that's what sets ApertureDB apart. I would also go on to say, like, one of our customers, like the way our team solves the problem, brings all the other, since we've been deploying this together with our customers, we've learned a lot of best known methods, best way of packaging and deploying, the challenges they would come to. In fact, as soon as someone starts explaining their end use case, I can already picture what the graph schema is going to be, and my team is even better at it. So, we can bring a lot of that expertise because of all the number of different applications we've seen, the number of different good practices, bad practices we've come across. So I feel like even though that's not ApertureDB per se, that's the Aperture Data team.
Right. Beautiful. I think it's really helpful to understand the whole process and how ApertureDB differentiates from the rest. I know time flies by so fast. I think I didn't even realize that we are getting close to an hour. I try to keep our conversations under the 50-minute mark. So any closing remarks or key takeaways that you would like to provide to our audience, or maybe even provide some references where they can find more information if they want to reach out?
Our time did go by really fast. We were talking about very interesting topics. So one of the things we've started doing this year is, we've done hundreds of discovery calls and picked up a lot of different things from different size companies, different sort of verticals and use cases, and different challenges at different scales of development, right? And we've been trying to capture these as effectively as possible in a newsletter that we publish. We try to do it twice a month, but lately it's been once a month. But it's on the Aperture Data page on LinkedIn. We sometimes share our own blogs, but a lot of the times we try to do more of what are we seeing around us? So your listeners can subscribe to that. Most of the information about us starts from our main website, aperturedata.io, but our documentation page, if you really want to learn more technical part, the user journey, or just try out our chatbot. I'm really happy with that chatbot we deployed, where it uses our LangChain vector search and retriever integration. And it's a RAG built on top of ApertureDB vector search. And there's a lot of room to improve once we grow the team more. And the thought I want to leave the audience with is, in general, AI model development is a very key piece. Deploying that, monitoring that, there is a whole list of challenges there, right? But what I strongly recommend is make data comprehensiveness and quality a key part of your AI strategy. And please don't ignore the cost of bad tools. Even if you cannot directly measure it, you cannot expect someone to deliver a 5-star meal if you just give them salt and flour and leave them to figure the rest out in a small time and budget. So just think about the challenges you put. If people can't even see their data, they can't even access their data. So it has to be part of the solution.
Beautiful, beautiful. I really like the way you have given the complete big picture overview about how all these things fall in place. Well, thanks for your time, and we would like to have you on board again some other time in future. I think thanks for these insightful conversations.
Thanks so much for the opportunity. I really enjoyed it. Thanks, Raghu.
As we wrap up this enlightening episode, a huge thank you to Vishakha Gupta for her time and the wealth of knowledge she shared with us today. Vishakha, your insights into scalable data solutions for multimodal AI have been truly inspiring. As always, if you have any further questions, you can reach out to Vishakha directly on her LinkedIn profile, since I'll be tagging her on the LinkedIn post. Alternatively, you could also reach out to me, Raghu Banda, on my LinkedIn profile, and I can put you in touch with Vishakha. As you know, you could also reach out to me on my other social media handles like Twitter, X, or Threads using the handle RK-Banda. You could also reach out to us on our website, XTrawAI.com, XTrawAI.com, where you will find humongous amount of other interesting episodes in the realm of AI. And finally, to you all, our loyal listeners, we deeply appreciate you staying tuned in. If you enjoyed this episode, please take a moment to review and share it with your friends. It really helps us reach more AI enthusiasts like you. And don't forget to subscribe on your favorite podcasting platform, whether it is Spotify, Apple Podcasts, or iHeartRadio, or you can even connect to us on YouTube. We've got even more exciting episodes on the horizon, where we'll be diving deep into the fascinating world of AI. So stay tuned, stay curious, and stay connected. Have a good morning, good afternoon, or good evening, wherever you are tuning in from. Happy predicting the future and stay connected. This is Raghu Banda, the host, signing off now.